Not so exceptionally distant from Earth, generally speaking, researchers have found a new planet known as Proxima b. Stargazers, as of late, uncovered the most keen picture at any point caught of Proxima b using the notable James Webb Space Telescope. This planet orbits the star closest to our Sun, and this wonderful picture offers a remarkable look into a world outside our nearby planetary group, raising questions and excitement among researchers overall. Yet, how did this telescope accomplish such an accomplishment? Could this picture open up a window into a spot that could have conditions appropriate for life? At last, what does this new discovery mean for how we might interpret exoplanets and the immense universe beyond? Join us as we explore the newly uncovered, clear picture of Proxima b caught by the James Webb Telescope, a strange planet. Proxima Centauri b sits inside the vastness of space surrounding its star, Proxima Centauri, a simple 4.2 light-years away from Earth. The first look at the clearest image of Proxima b, this far-off world, captured our imagination, raising inquiries about its likeness to our planet. Might it at some point be likened to Earth, facilitating seas and abounding with life? Adding to the interest, Proxima Centauri isn't alone in its journey. It shares a circle with another sizable planet, Proxima Centauri c. Proxima Centauri b gets about the same energy from its star as Earth gets from the Sun, making researchers inquisitive about whether this distant planet could have water or support life. As we explore the endlessness of space, we encounter various exoplanets circling stars other than our Sun. Within a bewildering 206 trillion stars scattered across the universe, the opportunities for these exoplanets seem unlimited. A portion of these planets wander freely through space, similar to enormous migrants. Proxima Centauri b stands out as a unique riddle in this broad exhibit of celestial bodies. Its year is surprisingly short, lasting just 11.7 Earth days, and it circles its star about multiple times closer than Earth does to the Sun. Thus, one side of the planet is constantly washed in sunlight, while the other remains in endless darkness. Adding to the planet's strange and possibly wondrous nature, Proxima b was initially found using the radial velocity method, an earth-shattering procedure in finding exoplanets. This method depends on noticing the unprotected movements of a star caused by the gravitational pull of a circling planet. As the planet circles its star, it makes a small but discernible movement, causing the star to move slightly in its orbit. Space experts spot this development by carefully studying changes in the star's spectral lines, a phenomenon called the Doppler shift. For Proxima b, these small changes in the star's range reveal the presence of this far-off planet, displaying the radial velocity method's effectiveness in uncovering worlds outside our nearby planetary group. Recognizing Proxima b was a critical accomplishment since it confirmed the presence of an exoplanet within the habitable zone of the closest known star to our Sun. This discovery ignited tremendous interest among researchers, specialists, and space enthusiasts overall. They are anxious to explore the potential mysteries Proxima b could hold and what this finding means for how we might interpret the universe and the possibility of life beyond Earth. Proxima Centauri b is an infinite wonder worth marveling at. Picture three celestial companions, Regulus, Canopus, and Proxima Centauri, move across the vastness of space, forming the closest star system to our own. As we look into the night sky, Regulus and Canopus merge into a brilliant guide, shining together in the Course constellation. These stars rank as the third most brilliant, stunning us with their splendor at a peak magnitude of 0.27. However, it's the modest Proxima that holds an intriguing secret. Moreover, alluded to as Alpha Centauri, this red dwarf from the T-type class lives just 0.21 light-years from its brighter companions. To put it into perspective, that's multiple times farther than the distance between Earth and the Sun. Its name, Proxima Centauri, meaning closest star in Latin, highlights its status as our closest celestial neighbor. Back in 1915, Scottish cosmologist Robert Thorburn Innes revealed this divine diamond to the world. Regardless of its proximity, Proxima Centauri remains tricky to the untrained eye, boasting an apparent magnitude of 11.13, far beyond the natural eye's visibility limit of 6.5. Nonetheless, it's an achievement in its own right. Red dwarf stars like Proxima Centauri are enormous forces to be reckoned with, effectively producing energy through strong internal convection processes. This star will happily maintain its position as the primary arrangement star for another 4 trillion years, exhibiting a lasting brilliance that spans the ages. However, the concept of habitability around Proxima Centauri comes with its fair share of challenges. Being a flare star, Proxima Centauri experiences sudden and unusual eruptions of energy. Its lower mass suggests that any potential habitable zone, where life-friendly conditions could exist, is much closer to the star compared to our Sun's habitable zone. Enter Proxima b, a planet situated within the zone at a distance similar to Earth's orbit around the Sun. But appearances can be deceiving. Proxima b battles with intense ultraviolet radiation, many times more intense than the sunlight reaching Earth. This extreme radiation poses a danger even to hydrogen atoms, imperiling the stability of essential elements like nitrogen and oxygen. Furthermore, simply occupying the Goldilocks zone doesn't guarantee a sustaining environment for life to thrive. Proxima b could lack the vital environment necessary to support life, manage climate, and cultivate a surface suitable for water. Without the protective shield of a vigorous atmosphere, any potential life forms on Proxima b would be exposed to the brutality of space, significantly reducing the likelihood of life as we understand it. The mission to uncover the secrets of Proxima b remains a driving force in the realm of space exploration. Among the tools fueling this invaluable research, the James Webb Space Telescope stands out, launched toward the end of 2021 after numerous delays. This cutting-edge telescope holds the promise of shedding light on one of the most tantalizing questions in cosmology. Does life exist on Proxima b? The path to uncovering the truth about Proxima b is far from straightforward. The James Webb Space Telescope underwent significant adjustments to ensure the accuracy of its images. According to a renowned theoretical physicist at Harvard, Proxima b requires a nuanced approach. Situated inside the habitable zone of its star, the planet has the potential to absorb and emit life-sustaining infrared radiation, making it detectable by the James Webb Space Telescope. This advanced instrument can capture faint light from the planet's surface, aiding researchers in their search for signs of water or an atmosphere. The crucial question of whether Proxima b has water plays a significant role in interpreting this nearby exoplanet. The presence of water substantially affects the potential for life as we understand it. Water, a fundamental component for life on Earth, if found on Proxima b, would greatly increase the likelihood of the planet being habitable or at least capable of supporting some form of life. Proxima b, located within its star's habitable zone, receives the same amount of solar energy as Earth receives from the Sun. However, due to its proximity to its red dwarf star, the planet faces intense stellar radiation and magnetic activity. These factors could challenge the stability of any potential atmosphere. Furthermore, the presence of liquid water is still in question. Currently, scientific models and simulations are being used to investigate different scenarios for Proxima's environment and possible water reserves. Some hypotheses propose the existence of vast oceans on the planet, while others suggest that any water may be trapped as ice or buried beneath the planet's surface. Directly identifying water on Proxima b presents an imposing challenge, requiring advanced telescope technology and specific atmospheric conditions. As our observational tools continue to advance, the mystery surrounding Proxima b's atmosphere and potential water reserves is expected to unfold, bringing us closer to truly understanding the nature of this captivating exoplanet. Yet, the presence of an atmosphere alone doesn't guarantee Proxima b's habitability. Adam Turner, an astrophysicist at Princeton University, cautions against assuming habitability based on an atmosphere alone. He warns that the planet may resemble Venus, with a thick, choking atmosphere and extreme heat, rendering it unsuitable for life as we currently understand it. Proxima b, beyond being just another distant exoplanet, emerges as a fascinating neighbor in our vast backyard, tantalizing us with the possibility of life-sustaining conditions. Its proximity to Earth makes it an attractive target for future space missions, sparking the interest of cosmologists and space enthusiasts alike. Although direct travel to Proxima b remains beyond our current technological capabilities, it holds a place on the horizon for potential interstellar missions. The challenges inherent in reaching Proxima b are indeed immense. A journey using existing spacecraft technology, exemplified by Voyager 2, would require an astounding 73,000 years. However, the spirit of innovation and human imagination drives space exploration forward, presenting potential solutions like solar sails. These ultra-thin sails could revolutionize space travel, pushing spacecraft at remarkable speeds and possibly reaching the Proxima Centauri system, where Proxima resides, in 20 years. This technological leap brings the dream of exploring an Earth-like exoplanet within our lifetime tantalizingly close to reality. The discovery of Proxima b has reignited humankind's curiosity with the universe, instilling a renewed sense of hope and fascination. It stands as a testament to our relentless desire to venture into the unknown, discover new worlds, and contemplate the existence of life beyond our home planet. While the James Webb Space Telescope represents a marvel in modern astronomy, it is not without its limits. Despite its extraordinary ability to observe celestial objects and shed light on the potential for life on exoplanets like Proxima b, it grapples with challenges in interpreting the presence of atmospheres and identifying conditions conducive to life. Proxima b, with its atmospheric similarities to Venus, serves as a stark reminder that an atmosphere alone does not guarantee habitability. Nonetheless, the telescope's exceptional ability to detect even the faintest signs of life, such as bright orbital mirrors that a potential development on Proxima b could use, highlights its potential. Our universe, with its enormous and enigmatic breadth, holds within it a surprising array of planets eager to reveal their secrets. These celestial bodies, known as exoplanets, orbit stars far beyond the reaches of our solar system, displaying a remarkable variety in their sizes and shapes. Some mirror the giant gas monsters like Jupiter and Saturn, while others resemble our very own Earth. Gas giants stand as perhaps one of the most enchanting classes of exoplanets, captivating cosmologists worldwide. These planets, similar in structure to Jupiter and Saturn, often outperform them in sheer size. Referred to as superjupiters, they loom so massively that they render Jupiter, the largest planet in our solar system, small by comparison. Alongside these immense entities reside the hot Jupiter gas giants, orbiting perilously close to their host stars, exposed to extreme temperatures capable of melting metals. Investigating the characteristics of such planets reveals a world on fire, filled with wild storms and searing heat. But the exoplanet category boasts diversity beyond these giants, including Neptunian exoplanets, similar in size to Uranus and Neptune. Among them live the hot Neptunes and small Neptunes, smaller cousins settled closer to their host stars than their larger kin, shrouded in mysterious atmospheres that continue to challenge our understanding. The quest to understand distant exoplanets like Proxima b has led scientists to develop cutting-edge technologies that expand our knowledge of the universe. As the field of exoplanet discovery continues to advance, methods such as the transit method, where astronomers observe the slight dimming of a star's light as a planet passes in front of it, have revolutionized our ability to detect and study planets outside our solar system. This technique has revealed thousands of exoplanets, many of which exist in the habitable zone of their stars, where conditions might be suitable for liquid water to exist. Such discoveries fuel the imagination and bring us closer to answering one of the most profound questions in science. Are we alone in the universe? In addition to the discovery of planets like Proxima b, astronomers are constantly refining their search for biosignatures, indicators that could reveal the presence of life on distant worlds. By studying the atmospheres of exoplanets, scientists can identify gases such as oxygen, methane, and carbon dioxide, which are associated with biological processes. The James Webb Space Telescope, with its powerful infrared capabilities, is expected to be instrumental in this area of research, enabling the detection of these gases even on planets that are light years away. If scientists can confirm the presence of biosignatures in the atmosphere of an exoplanet, it would provide strong evidence that life could exist elsewhere in the universe. Yet, even as we look outward toward the stars, the search for life in our own solar system is ongoing.